Hello and welcome. My name is Burhan. I'm an assistant professor in the Department of Medical Radiology and Imaging Technology, GNA University. Continuing with the topic of CT instrumentations, in this lecture we will be studying about data acquisition system. In the previous videos we discussed about the imaging system in which there were multiple components and finally the X-rays are reaching the detectors, where from the detectors a measurement is created. Now from those measurements after the detectors there is the data acquisition system. So basically the data acquisition system is a set of electronics between the detector and the host computer, and it includes multiple electronic devices like the amplifier, analog to digital converter, which is known as ADC, and then the DAC. DAC is digital to analog converter. Then we have generator and sample hold unit. Let's try to find out the function of each component. So the first component is amplifier. As the detectors receive the radiation, they convert the radiation into an electrical signal of the same intensity as that of the radiation, but now that signal needs to be amplified so that it will be further forwarded for the post-processing and finally the image creation. Here the signal from the detector goes to the amplifier for the signal magnification, and then it is sent to the sample hold unit. The next component is known as sample hold unit. Now about the location, the sample hold unit is located between the amplifier and the device known as ADC, which means analog to digital converter. This particular electronic device helps us to assign sampling and assign shades of gray to the pixels in the digital matrix corresponding to the structures. So basically the sample hold unit will verify the signals and will only allow the useful signals to proceed further. Rest, the unwanted signals, will be terminated at this particular electronical device. The next component is known as ADC. ADC means analog to digital converter. This particular device has a function that it converts the analog signals which were created by the detector into the digital signals, and those digital signals will then be forwarded to the computer for image formation. So here is a flow diagram that is showing different components of the imaging system, including the host computer as well as console. So the host computer here will act as a center point, and it will be interacting with all the other components. Like the first, from the host computer, the signal arises for the scan controller. The scan controller will go into the DAC, that is the digital to analog converter, and will eventually control the gantry. In the gantry, it controls the motion of the X-ray tube, the acquisition of the detectors and other electronical devices. The scan controller is also responsible for controlling the voltage of high voltage generator, which finally gives the signal to the X-ray tube. Coming to the next, from the X-ray tube, the X-rays are generated, they go into the patient's body, and finally they are detected by the detectors. After the detectors, there is a creation of analog signal, and those analog signals are given to the sample hold unit, which will further forward it to the ADC. ADC will give it to the array processors, and finally that signal will be given to the host computer, which will finally be processed and image will be formed. Again, on this end you will be able to see that the host computer is responsible for communicating with the storage devices. So with the help of host computer we can store a particular examination, and in the future we can retrieve a previously done examination. and the operator is able to command the host computer from a particular portion that's known as console. From these particular electronical devices collectively are termed as data acquisition system, because these are the devices which are directly linked between the detectors and the host computer. The next is slip ring technology. From the historical perspective, there was no continuous motion available until the fourth generation. Now, after the fourth generation, 1990, the slip ring technology was introduced. By the introduction of slip ring technology, it allowed the gantry for continuous motion, and that continuous motion gave rise to two types of CT scan methods, which is known as helical or spiral CT. So basically these slip rings are large rings of conductors which allow for the continuous transmission of electrical signals and electrical current to different components of gantry. And these slip rings are connected here with the brushes which keep a close contact with them. So here we can do power and signal transmission to the gantry by using brush on static rings. No need for start and stop the rotation. And here we can increase the scan time as fast as 0.3 seconds. So slip ring technology, this is an electromechanical device consisting of circular electrical conductive rings and brushes that transmit electrical energy across the rotating interface. Here the advantages are that there is a reduction in the rotation moment and it eliminates the interscan delay, which was observed till the fourth generation of CT. Now, the gantry contains multiple electronical devices which have to work continuously for a long period of time. Along with that, we have X-ray tube which is producing a very higher exposure than the diagnostic X-ray. So, the gantry cooling is required. In the past, air conditioner is placed in the gantry tube, but now we go for the rotating anode X-ray tube, so we require to circulate the air from the scanner throughout the gantry. For example, CT scanner uses large low pressure blowers filters that circulate the in front cover of the gantry, directly cools the air through the detector module and the gantry electronics, then exit through the top cover. So remember, the maximum temperature of the gantry should be 23 degrees Celsius and the humidity levels should be at 60% only. So from the imaging system we have discussed the gantry. Now the second major system is patient couch. So patient couch should have different features, like it should have a weight bearing capacity of 450 lbs or 204 kgs. Scannable range means from the whole length of the patient couch, the CT scan has a capability of scanning 162 centimeters in a one single exposure. The patient couch should be strong and rigid, and it should provide safety and comfort to the patient. It has both movements, the vertical as well as horizontal. Couch top is usually made up of carbon fiber as a material of choice. The reason is that the carbon has a very low atomic number, so that means it will not interfere with our imaging sets while we are taking projections from different angulations. Also, the carbon fiber is one of the strongest materials, so it can hold a patient weighing up to 204 kgs. Next major system of CT instrumentation is the computer system. Now, the computer system is centrally located and it receives digital data from the data acquisition system, and those data are then to be processed and reconstructed into a cross-sectional image. What are the functions of the computer system? The functions of the computer system are that it has to do the reconstruction and the post-processing of the image, control all of the scanner components, that means giving them signals control of data acquisition, processing, display, and data flow directions. Now, the types of the computer that we use in the CT system are mini computers. Why do we use the mini computers? The reason is that in a single projection, in a single scan, we are utilizing multiple projections. At the end of each projection, we have to do thousands of calculations. Those thousands of calculations are not possible by a normal computer. That's why we have to use more advanced version of the computers. Those are known as mini computers. Computer system is composed of hardware and software. The hardware and the software is provided by the company which produces the scanners. Now, the last component of the CT instrumentation is known as image, display, recording, and storage. So image display is simply the output from the computer which we get onto the monitor. In the very next step, we have to provide a hard copy to the patient. Then we have to facilitate the storage and the retrieval of the digital data, and we also have to communicate the image within the network. So first, the image display is simply the monitor onto which we are able to perceive those cross-sectional images. For the image recording purposes, we have different types of printers. The laser printers are mostly preferred. These are solid state printers and gas laser printers. Now, in early times, the image storage was done on different medias like the magnetic tapes. Then an advancement came and we started to use magneto-optical discs. Then after that we started to use the CDs, the compact disc. In the most advanced and presently used is PACS. PACS is known as Picture Archiving and Communication System. Here we create a network between multiple departments, and we don't need to provide a physical copy. Rather than that, what we can do is we can digitally send the image from the radiology department to any other department within the hospital or outside the hospital. So the images are acquired in the CT room. From the CT room, for the reporting, they are digitally sent to the radiologist room with the help of PACS. In the radiologist room, the radiologist creates a diagnosis from these images, and from that, the radiologist digitally sends those images to the referring physician. This is the workflow of the PACS. In the conclusion, we can say that the imaging system is responsible for acquiring the image, the computer system is responsible for processing the image display and recording, storage and communication system is responsible for viewing the image, recording of archived data, storage of the data, and communication of the image respectively. On an average, if we will try to find out the cost of a 64 slice Philips Brilliance starts for 3 crore rupees. Similarly, B16 machine starts from 2.5 crores within India. Now, here is a highlight of the specifications of a CT scanner. We first have a major component that's known as gantry. Gantry houses the primary systems, which includes X-ray tube, gantry aperture, weight limit of the patient couch, generators, output capacity, kV, MAS. X-ray tube has anode storage capacity, focal spot, detectors. From the detectors, the materials, dynamic range, slice thickness, display resolution. Now for the applications, the CT has some of the complex applications like we can perform virtual colonoscopy, we can do the dental planning, CT perfusion, cardiac viewing, lung nodule assessment, image storage capacity and processing. So this was the end of the CT instrumentation. Thank you so much.